repeat, it returns tuple. Tuple having two values. First one is the number of rows. Next one, number of columns. Here also same. This is so called as a 2 by 3 matrix. Chapman Sarji, what matrix? 2 by 3 matrix. Move on. Rows and columns. And to show how many rows and how many columns, and row by columns actually, right? Rows by columns. So there are two rows, row number 1, row number 2, 3 columns. 1, 2, 3. Yeah, this images I brought it from, there is a good website. Website name is a Math is Fun. The website name is a mathisfun.com actually. There you can find. I really like that website and I have captured a few images, which is really very good actually. Please understand this point is important. Can you read everyone? Scalar, vector, matrix. One more time. Scalar, vector, matrix. A single number is nothing but a scalar. If you're asking what is your age, I can say 16, 17, 18. Just imagine. Just imagine. So single number, right? That is called as a scalar value. What value, Sarji? Scalar value actually. The next one is what exactly, no sir? Vector. What do you mean by vector? You know, a list of numbers. Chappan Sarji? A list of numbers. I mean to say group of numbers. Online team, hold on. Boss, offline or online? Oh, all right, all right. I'm sorry. Just checking. Okay, move on, please. Where are we? When you're talking about the vector, did you remember list to data structure? Yeah, simple. So when you're talking about the vector, look at the diagrammatic Sarji. Scalar. When you're talking about the vector, either it can be single row, Chapman Sarji, single row, or else what exactly? Single column. Single row or single column, right? That is nothing but a vector. Vector. When you're talking about the matrix, simple group of rows and columns. Chapman sir, group of rows and columns. Nice. In fact, a vector is also called as a matrix, but it having only one dimension. So please understand that. Okay. Find adding matrix actually. Adding matrix. Yes, you can add matrix, but ensure that when you are adding matrices, two matrices actually, right? So number of rows and number of columns should be matched. When I covered this example, you know, Sarji, during NumPy, what exactly? I have created two arrays, and in between we applied plus operator, and in between I called add function, not add method. What function? Add function actually. So look at my screen. Daniel, this one is a 2 by 2 matrix. This one also 2 by 2 matrix. Then 3 plus 4, 7, blah, 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 respectively. 6 minus 9. What is the result actually, Sarji? Minus 3. Good. So this is called as a adding the matrix. But when you are adding the matrix, so number of rows and number of columns should be matched. Otherwise, not possible. Otherwise, what, Sarji? Not possible. The shape should be matched. What should be matched? Shape. Yeah, you can walk through this theory. It's a easy. Don't think too much. The matrix notation is very easy. Next one, negative matrix. Daniel, I do have a matrix. Can I change the sign for every value? Yes, you can do that. So just you have to provide minus, and you will get like a negative matrix. A negative of the matrix is also called as a simple. It's a very simple. Just you need to apply, change the sign. Next one, subtracting. Same story. So you can take two matrix. You can take what exactly, sir? Two matrix, and you can just hit to apply minus symbol. It's quite interesting. Are you following? Good. The next one. Multiply by constant. One more time. Multiply by. I mean to say, I would like to take a single value. With that value, I wanted to multiply with all other value. So look at my screen. 2 into, so 4019. 2 into 4, 8, and 2 into 0, 0, respectively. 2. Next one is a minus 18. This is possible. This is what exactly is possible. Can I confirm? These are all when I covered, in eppudu cover chesina telusa. Go back to the NumPy. And you can just have to walk through important methods, and here you can see adding matrix, you can see, so adding a constant, you can see adding and subtracting. Here I have explained, right? Multiplying with one constant value. Please walk through this, you will get an idea. Good. Yeah. This is not that much easy, and let us spend here some time. Can you tell me what is the topic name? Multiply. So in matrix, one of the tough topic is called as a multiplication. That's not that much tough actually, but people will think like that is a difficult. It is very easy. Let me explain. Just ignore this example. Let me explain in a very general way. Hold on. In a very general way, let me explain. Then I will back to the discussion. Good. A real-time example. Just look at this table. Monday, Tuesday, Wednesday, Thursday. Think like there is a fruit stall. And that owner, he is going to sell, these are all fruits, first type, second type, third type actually. And first type of fruit on Monday, total how many sales? 13. Tuesday 9. And the third type of fruit, so, on Thursday how many sales actually? 3. And so and so Wednesday how many? 0. Maybe fruits over, otherwise already that fruits are not imported or exported actually. Good. So please understand. Now every fruit back end, it is per cost actually. Apple, the first type of fruit, each one is a $3. Chapman Sarji, each one is $3 actually. The next one 4. The next one $2. Listen carefully. Now it's a right time. Hello Daniel, I wanted to know what is the total Monday business actually. I wanted to know total on Monday what is the business. Can you tell me what we need to do? 3 into 13. Next one plus, no, repeating again. 3 into 13 plus, next one 4 into 8 plus, next one. Yeah, exactly. Remember that calculation. Now you can just observe here. So apple, first type of fruit, second type of fruit, third type of fruit, and this one is a so and so type business actually. Yeah, 3, 4, 2 and 13, 8, 6 actually. Now look at the table, Sarji. Meeru diagrammatic representation chudandi. And here I have taken something like a all fruits cost, each fruit how much actually, and here I have taken kind of some the total day actually. Everybody please focus on this. 3 into 13 plus 4 into 8 plus 2 into 6. Then what is the total result actually? 83. Same thing like that. This one is a Monday sales, right? Can you tell me what is the next one? Tuesday. Same process actually. 3 value I need to multiply with 9. 4 value I need to multiply with 7 actually. This is the way in real time they are using especially. Now, but there is one small rule you need to understand. What is that rule, Sarji? Go back here. Then I hope you understand. Let me just explain the topic actually. Now, please understand this. Multiplying the matrix. Multiplying a matrix by another matrix, we need to do the dot product actually of rows and columns. Yeah, come on, get ready, Sarji. First one always we need to pick the row. The next one always we need to pick what, Sarji? Column. 1 into 7 plus 2 into 8 plus 3 into 11. What is the result actually? 58. Good, hold on. Now, especially when you are working with multiplication, matrix multiplication. Matrix multiplication. Remember one thing. Imagine A by B matrix. A by B matrix actually. The next one B by C matrix. Next one is what exactly, sir? B by C matrix. Sir, do you know what is the result actually? This B and B, it is going to be cancel, and A by C is the result actually. Can you tell me, sir, what we are going to get? A by C. That result we are going to get. If you want, I will repeat one more time. I'll repeat chestan chudandi. 2 by 3. Can you repeat again? 2 by 3. A means rows and B means columns. And here 3. Definitely 3 is required actually. Otherwise you will get an error. 3 by 4. Then what is the result you are going to get, Sarji? Like how B by B and how 3 by 3. Tell me what is the result? Exactly. 2 by what exactly? Man 4. This is the rule. This is the rule when you are working with especially matrix multiplication. If you didn't follow this rule, matrix multiplication is not possible. Matrix multiplication is what, Saji? Not possible actually. Man, 6th standard actually. Not 6, I guess. 7th or 8th standard. So you have to understand this. Arrays also will follow the same fundamental. Okay. So I request you guys kindly please walk through these examples. Are we doing practically? Yeah. During machine learning, I will explain more and more. A real-time example, kindly please make a note. Now here I have explained one small little theory. Small little theory. What is that theory, Sachi? A matrix is very simple. We can close in another 5 to 10 minutes. Another 5 minutes, then we are entering into the feature engineering. In general, to multiply a matrix M by N, matrix with N by P, En. And here rows and columns. Here columns and here rows should be matched, Sachi. Right? Once it is matching, then you will get the result. What is the pending one? M and P actually. This is the result we are going to get. And yeah, please make a note. 1 by 3, 3 by 1. And what is the matrix? 1 by 1. We are going to get a single value within the matrix actually. Now, yeah. So 3 by 1, 1 by 3. Can I ask a question? What do you mean by 3? Yeah, good. You should know, I guess actually. 1 by 1 will be cancelled. What is the result we are going to get? 3 by 3. What is the result, Saji? Please, I request you walk through. Types of the matrix. Yeah, good. So this one is a matrix is the array of numbers. Types of the matrix, let me talk with you. Any idea what it is? Do I need to calculate manually? No. So there is a predefined functional method I need to cross verify. Diagonal we already done. After diagonal, what I covered in area? Any idea? Trace I covered. Did you remember? What is a trace? Sum of the diagonal actually. Okay. Man, you guys, revision required actually. Transpose means converting rows into columns into. Good. You guys kindly please walk through. Square matrix, a kind of some 2 by 2, 3 by 3, 4 by 4. I mean to say number of rows and number of columns if it is matching, that is so called as a what exactly? Square matrix. Okay. Next one, identity matrix. An identity matrix has a 1 at the diagonal and 0s at all position. Repeating again, what do you mean by identity matrix, Daniel? It seems to be 1 at diagonal and 0s at all position. That is so called as an identity matrix. Daniel, all these are important, not much important, Sachin, but you should have kind of some small recap from your, schooling level actually. Diagonal matrix. A diagonal matrix has a 0 anywhere and not at what exactly main diagonal. Think like, so main diagonal, this is the 281, some any number, and these are all zeros actually. Can I ask you a question? Identity means diagonal position 1. Diagonal position 1. Any value 1 actually, diagonal position. And this one is what exactly, Sarji? Diagonal matrix. At a diagonal, some different values would we have, and all other values are 0. Scalar matrix. So the same value. Rather than 1, same value. 555, 333, 444, something like that. Zero matrix. Also called as a null matrix. All are zeros actually. That's it, man. That's it. So seems to be closed within 10 minutes. Why? Because not that much important actually. Okay. Can I tell you, we done this. Now I need to start. This is the running topic. The good news is we are going to touch the code. Almost we got some gap, right? 1 week actually. We didn't even execute any example. I can specify like this. We done the previous topic. Can you read the topic name? What is the topic name? Feature engineering. Okay. Daniel, how many days? Just 2 days topic. Today and maybe tomorrow we can close this. We'll see. Let me try my best. Feature engineering. Good. Let me take a data set. First I will explain what is feature